Hey guys, welcome to IndusCore Tech. In this video, we will use TensorFlow to perform image classification with a pre-trained MobileNet model using the ImageNet dataset. So here I have three different folders, one for animals, electronics component and tools. And I will conduct some little tests by using my code to verify the accuracy of the model, if it predict or classify the images. So everyone know that this is a cat, for example, but not everyone knows that this is a transistor. And the same applies to my IA model. So we are going to test the model's limit, and for that I will, for example, make you a demonstration. So here I will just conduct my prediction to my first image, that is a cat. I will run it for you. Here it will took a little of time because I'm using my CPU and not my GPU for the calcul. So I will have a probability of 55% that this is a tabby. So it's kind of a race of the cat, and it's a good prediction, but for 54 it's a little low as a prediction. Yeah, so now I will change. I will try to predict the transistor. I will run it, and here you will see the result. Yeah, you can see that it's a combination lock, and it's a 36%, and it's a 7% a dumbbell, hair slide, padlock, and switch. Yeah, you can see that the model is not really correct, but just stay till the end and I will explain you why, and I will make you a comparison between all the folders and the results I get, and in the next video I will use other model to compare between them. And so my aim is to have a model that can detect and predict or classify all these electronic components that are not usual to see in the IA models. So first I import the required libraries. We have TensorFlow, that is used to load and run the deep learning model. We have also NumPy, that is used for numerical operation, and finally we have CV2, that is used to load and manipulate images. Now here I will load the pre-trained MobileNetV2 model. So this model was trained on the ImageNet dataset, which contains over 1 million images across 1000 classes. So we are not training anything here, we are only using the model for inference. Okay, so let's go. ImageNet. And now I will load an image from my local disk using OpenCV. So the image is loaded as an MP array in BGR format. OpenCV use BGR instead of RGB. Image. So here I will try to predict this image. Now we read it with read image. That's it. Now I will resize it. Image equal to 7. Resize. So you need to know that MobileNetV2 expects images of size 224 by 224 pixels. So we resize the image to match the input size required by the model. Here for the preprocess, the image is using the same normalization that was applied during training. So pixel values are scaled and normalized so that the input matches so it will match what the model expects. Applications, mobile V2 pre-process input image. And now I will add the batch. So in neural networks always process images in batches. So even if we only have one image, we must add a batch dimension. So just I will explain it after I will write it. Expand this image axis equal. So if we are not using this command, this one, we will just have like this information in our image. So it will be the 200, sorry, I did make a mistake here. So it will be like 224 by 224 pixels, and the thing is for the three colors RGB. And what we need to do by adding one dimension to our axis, so that we can create this. It will become this way, and this is the correct way to treat our model. What I want to say is that we can also add a lot. So you can imagine that this batch is like a box where you put a lot of images. So here we will just choose to put one image because we are just doing inference. We are predicting what is this image. But for training, for example, we can put a lot of images and we will gain time by doing it. Of course, it depends on your hardware. So for example, we can do like 16 images at the same time for our treatment. So this is just an example and to explain why we are using this command. Okay, so we need to add one dimension to our bunch, for our batch, sorry, so that it can work correctly. So here we will do our inference. So the model will predict the image inside the batch. So the output is a vector of 1000 values one for each ImageNet class representing class probabilities. So now we will decode it. So decoded predictions. This raw output of the model is not human readable. So this function maps the prediction class indices to ImageNet labels, and we will return the top 5 most probable classes. So now we will display our result. So it will be ImageNet ID, also the label and the score. Here we iterate over the top prediction on print the class name, the image ID, and the confidence score as a percentage. So this is classification and like not object detection. Okay, let's print it. Print our iteration. So there's the label and the image. Wait, it will be image net ID. Okay. This is the probability, and of course we'll do the scoring. So the score will be multiplied by 100 so that we will have percent. On just two numbers after the dot. Now we'll show the image. Sorry. Wait, okay. Destroy our windows. Okay, so now we have our code. I hope it will work. Just let's see if it will predict this image. As you can see, it predicted that this is an oscilloscope, and the probability that this is an oscilloscope, sorry, it's a 93%. So it's a good prediction. So what I want to add before is that this model performs image classification. So it predicts what the main object in the main image is, but it does not locate the object or draw bounding boxes. So it's not detection of the object. It will just say what is the object. So in summary, what we did today, so we loaded a pre-trained MobileNetV2 model, pre-processed an input image, and performed image classification using ImageNet without any custom training. So now what I will do, so here is the image of the that we predicted by 224 by 224 pixels. So now what I will do is that I will predict all these images, and then I will give you the scoring of each prediction of my model and tell you at the end if it's a good model or not. And maybe there will be also another video next time where I will use another model more accurate than this one to do a better classification. This page lists all the classes found in the ImageNet dataset. You will find the link of this page in the description, and this page lists all the classes found in the ImageNet dataset. For example, when I use Ctrl F and I want to search the screwdriver, you will find that the ImageNet contain class called screwdriver. So they did train their model on images of screwdriver. So this is why our model can predict images of screwdriver. And if, for example, I will use it for capacitor, we have no results. And the same goes for like transistor. There is no results. We can conclude that the dataset is very important, also as the model, of course, and you will generally be required to create your own dataset for your own projects in an industrial setting. Okay. So to conclude, I have one folder called samples, and inside of it I put 3 other folders: animals, tools, electronics, and in each folder there is 4 pictures. So the first one in animals, the first picture is the picture of a cat, and this is the prediction that I get. Tabby for 54%. It's quite good because it just didn't give me the race, sorry, the name of the animal, but also the race, because this race of cat is called tabby. Then in second position I have the Egyptian cat. It's quite how to say it, it looks like a tabby, but it's not a tabby. You have then after for 30% tiger cat, snow leopard. It's totally false. You can see that the probability is 0%, and also length, same thing, 0%. Then this image is a cow. We have first prediction for 65% that it's an ox, a Boston bull for 6%, sorrel for 2.5%, ambusher, and Great Swiss Mountain Dog. Now for the last one, it's totally false. This one is quite funny because this is a picture of a lion, and for the first prediction I got Al-Hasa for 10%. It's quite good because even the model know that this is not a lion. You can see that why he gave me 10%, because Al-Hasa is this dog. So Pekingese, it's also a dog. Tibetan Terrier 6%, also a dog. Norfolk Terrier and Keeshond for 4%. So my model didn't predict the image of the lion, so he get it all false. And this one is the eagle. For the first prediction, for 38%, he gave me the name kite, but the funny thing is that this is a bald eagle, and he predicted for in second place for 30.44%. Then for the third place you have the quail, macaw for the fourth, and cuckoo for the fifth place. So here for the tools, I will make it quickly. So for the hammer, he predicted 97%. This one is a saw, and he detected as a can opener for 32%. Screwdriver for 95%, and the power drill for also 95%. For the tools, it's quite good. The prediction seems really pretty and really accurate. And here for the electronics, you will see that he didn't predict well all the component. So for the oscilloscope, he get it for 93%. Here, this is a transistor, and he predicted as a combination lock. This is a capacitor, and he detected as a screwdriver for 22%. And this is a coil, and he detected as a screw for 52%. You will see that when he didn't get all the images that he needs, our model will start making some hallucination, and he was supposed to give you an answer, and he must give you an answer, but sometimes the answer is not correct. So the observed results: MobileNetV2 performs well on common categories such as animals and tools. Prediction accuracy decreases for electronic components. Explanation: the model is pre-trained on the ImageNet dataset. ImageNet contains many object classes, but not all industrial or electronic components are represented. When a class is missing or underrepresented, predictions become less accurate or less confident. So this is why we get this result. So the key takeaway: pre-trained models are powerful, but they are limited by their training data. And the next step that we will do in the next video, we will use EfficientNet. It's another model, a more advanced architecture to improve feature extraction and achieve better prediction accuracy even without additional training. So thank you guys for following me. Don't forget to share the video and subscribe. Wassalamu alaikum.